Hello and welcome back to my channel. My name is Piyush and this is day 12 in 30 days of AWS Terraform. And this is the continuation to the previous video, day 11 video, in which we started with Terraform functions. So we covered some functions, we did the demo and we understood it, and we'll continue from the rest of it from here. Okay. So make sure you are watching, like I'm saying this in every video, but make sure you are watching the video in every single sequence that we are using. Okay, because what happens, when I publish any video series. Okay, so let's just talk about it for a few seconds and then I'll go back to video. So what happens is, like, let's say I have published the CKA series, which is one of the popular series on my channel. That video series has 59 videos, 59 full length videos. It's more than 30 hours of content, maybe 35 plus hours of content. People start watching from any random video out of it. Let's say someone who's a new Kubernetes user or a beginner to Kubernetes start watching it from day 30, and then they complain like, you have not explained the basics, you have not explained what is a pod, what is a deployment. And I am just tired of explaining this to everyone, that do not start the playlist from the middle or from the end or from any random video. Start from the beginning if you want to understand every single concept. If you are a beginner, then you should start from day 1 or day 0 video. Otherwise, you will not understand the fundamentals, because the way I publish the video series, I cover each and every topic in bits from day 1 onwards, right? So that I don't have to explain in each and every concept in every video, and it is not possible as well. So that's why we are doing this. Okay, so make sure you start the series from day 0 onwards. Okay, let's go back now. Okay, so we started with Terraform function in day 11. We covered some functions, like we covered lookup function. So let's mark it in green. Okay, and I don't think the text is visible anymore, so let's just change the color of it. So lookup function we did, and then we did type conversion. No, we did collection function. So let's mark this in green as well. And then we did string function. Okay, so majorly we covered these three, and in this video we'll cover the rest of the functions: validations, file, date and time, type conversion, and numeric. Okay, so let's go back to VS Code, and yeah, I'll just reuse the same folder. Let's just change the name of this folder from day 11 to day 11-12. Okay, now yeah, so in this video we'll start with the validation functions. So validation function is something that helps you with pre-validation of something, right? So similar to what we did in the Terraform, like S3 naming convention over here, right? But over here it will just make the changes, it will not throw any validation error. If I want that validation error to be thrown out, if the name is not as expected, then we'll use validation function, and I'll show you how we can use that. So we can use, and it has to be done inside the variable declaration, not over here. And let's see how we can do. So first let's go to variable.tf. Okay, let's create a variable name instance type. Okay, instance type, and let's add a default value, which is t2.micro. Now I want certain validations to be done in this instance type whenever user is providing any value. Okay, so I'll start with validation keyword, and inside validation I'll start with this. Now you can add multiple validations as well. So let's just copy this. Let's say you need to add 2 validations. Currently it's throwing error because I have not added anything inside it, right? So you need to provide certain things inside validation. So it is expecting a condition, like when the validation will be occurred, right? So what is the condition when the validation will happen? So let's say the first validation you want to do is the instance type that you are using, it should not be greater than 20 characters. So let's say between 2 and 20 characters. So this is the validation that you need to do. Okay, so for that you need to use, oh, my book fell down, that's okay. So you need to use the length function first. Okay, so length for var.instance type greater than equal to 2. Okay, it should be greater than or equal to 2. And so we use logical and. So and means we are using logical and, we are combining two conditions together. Okay, so it's not or, it's and. That means both the condition has to be true. So and again, length function var dot instance type should be less than equal to 20. Okay, I hope this is making sense now. What are we doing? We are saying the length of var.instance type, which is t2.micro. This is the instant type. Currently we have 1, 2, 3, 4, 5, 6, 7, 8 characters, right? So we are saying the length should be greater than 2 characters. I mean the length of characters inside that variable, and it should be less than 20. Okay, my daughter woke up in the middle of the night, so I had to go put her to bed. And now I am back, and it's been half an hour, and I forgot where was I. So please forgive me if I just repeat certain thing, of if I skip anything. Like, I try not to skip anything, but if I repeat anything, please bear with me. Okay, I think we were talking about this condition. Okay, so the instance type that we have selected is, let's say it's between 2 and 20 characters of length. So here we have few characters, some 8 characters, I believe. So it's within 2 to 20 characters, right? So that's the condition. The next thing is we need to set the error message when this condition violates. Okay, so let's say if there is some value of this variable which is either less than 2 or greater than 20. So what error message should be printed as the validation error should be provided over here. Okay, so we can say instance type must be between 2 and 20 characters. All right, yeah, so that's first validation. You can add another validation. Let's say you are specifying that only T2 or T3 instances should be allowed. Okay, so that's, let's say, another condition. So inside that, we can use a regex, which is a regular expression, and you use a function called can. So first let's add regex. So there is a regex function in Terraform. So regex, if you want to know more about regex, and if you don't know about it, you can just Google it. So it works with most of the programming languages, even with shell scripting and everything. So yeah, regex is a regular expression in which you add some wildcard characters, and it will take care of it. Okay, so let's say you want to see that the instance type should start with T. So either T2, T3, T4, and so on, right? So it should start with T. So that's why you can add something like this inside regex. You add double quotes, and then the starting character will be with this symbol. Okay, and T is the first character that we are expecting, T2 or T3. So now we are also saying that it should be either T2 or T3. So that's why we can add 2-3 inside the square bracket. So this will say first character, and this will say so 2 or 3. Okay, now so this is the first string, and then it should be dot. So T2.micro, T3.micro, and so on, right? So so there is dot, but you cannot directly use dot. You have to escape this character. This is a special character, right? So the way we escape it, using 2 backslashes. Okay, so that's how you will use regex. But then you need to check this regex in something, right? So you need to check this regex in instance type. So that's why you use another function with it, which is can. So can is, this is the first expression, comma var dot instance type. Okay, am I making any syntax error? Let's see. So this regex, this is enclosed over here. Oops, sorry. Like this. Yeah, this should be correct. The error it is throwing because we have not added the error message yet, right? So let's add error message. Error message is, by the way, if you want to see like why it is throwing the error, So you can just hover the mouse around it and it will show you, right? So now it will show you, and this is coming from the Terraform extension. It is not coming from Copilot, it is coming from the Terraform extension that we have. So it is saying required attributes, error message not specified, and error message is required here. Okay, so let's add error message, and the value is instance type must start with T2 or T3, right? So that's why we have added the validation. So just a quick recap, we added a variable, added the default value, then we added a couple of validation conditions and the error message that it will throw if that condition is not specified. Now, how do we test it? Let's say we have a variable over here. So let's remove this one. We don't need this. Let's add a variable instance type and let's use something else. Let's see T4.large. I'm not sure even if this is a valid one. Oh, could be, but let's see. Okay, and let's clear the screen and run tfplan. So ideally it should throw the error. Let's see. Okay, so this is a custom error message that it is throwing. It is a custom validation message. So it is saying instance type must start with T2 or T3. Okay, so that's the validation. This was checked by the validation rule at variable. It is showing the exact file and exact line as well. Now, if we do instead of T4 large, let's say we are using T2, but we are doing some value which is greater than 20. So now it will pass the first validation, which the second validation it will pass, but it will fail on the first validation. So let's run tfplan again. And here it is. You see, instance type must be between 2 and 20 characters. So both of the pre-validation error we have checked. Okay, so let's just use T2 micro. And if I run it again, this should work without any issues. Okay, it's working. No error now. So that's the validation functions that we have checked. Now let's check the other one, which is we'll check again some operations, some functions that is ends with and sensitive. Okay, so let's use this variable. Okay, I'm gonna copy it at the end. And so what are we doing? We are using a variable name backup name, and then we are adding a validation. What validation we are adding? So it's another type of validation function. So it is adding a condition. Let's say ends with var.backup name hyphen backup, and backup name must end with hyphen backup. Okay, so we are saying we are creating a backup variable, but the name should end with hyphen backup. Okay, and that's the validation condition. So how do we test it? So let's use this variable name inside Terraform var backup name is equal to let's call it daily underscore backup. Okay, and let's run tfplan. This should work because the backup name has hyphen a backup at the end. But if I use hyphen backup instead of underscore backup, now this is failing with the validation error. Backup name must end with underscore backup at this line validation rule field, right? So that's another type of validation function which is named as ends with. So another validation is with, actually it's not a function, it's a type of feature within variable. Okay, so when we are adding variables over here, like so currently we are using the default values and it will be printed on the screen as well. It will be printed in state file as well. What if we want to keep some values as sensitive? Okay, so let's say variable credentials, like you don't put the credentials generally in the variable files. Like I'll show you why. So variable equal to credentials, let's add a default value is equal to xyz123, that's the value, but we are also saying sensitive is equal to true. What it does, so till now we were only using variable with the default value and somewhere we were using type and description, right? So this is the first time we are using sensitive equal to true. What it will do, let's use this variable and let's use this in the output file as well. Let's create an output variable. Output name is credentials and value is equal to var.credentials. Okay, so let's run tfplan again. Okay, now it says output refers to sensitive value. That's why it is not showing the output of that variable. If you intend to export this data, annotate the value as sensitive by adding the following argument. It's saying add sensitive in output as well because the variable itself is sensitive. Okay, so if I add sensitive over here, let's run the tfplan again. Okay, now it is saying backup must end with -backup. This is the validation error that was coming from earlier. Just corrected it and running the tfplan again. Okay, so we are mostly concerned with the value of credentials. You see over here it is not showing anything and it says sensitive value, so it will not come in the logs. It will not be printed on the std out or std error. That's why we use sensitive. But again, it's not really encrypted, it's encoded. It's base 64 encoded, anyone can decode it, plus it will be there in the tf state file. So use that with cautions. I'm just telling you the example. Like there could be other use cases, but I'm just saying it as an example. It's not the actual credential that you store in the variable. Okay, now that was validation, and so we cover a couple of more validation and credential type. Okay, the next assignment is about, yeah, type conversion functions, right? So let's create two more variables inside variables.tf. I'm going to create these two variables. One is user location and another one is default location. In user location, we have some duplicate values, like US East 1 is there twice. It's list, but it has duplicate values, right? And this is again a list, but a single value. So if you remember, list does not allow duplicate values, only set allows duplicate value. Okay, so if I were to concatenate this, let's see how does it work. Okay, so let's go ahead over here, main.tf. Okay, inside locals we have a lot of variables in local now. Okay, and let's do all locations is equal to, and now we're gonna concatenate all the locations and then we'll see what is the result. So we use concat function, and inside that we provide, you can hover the mouse and it will show you, you provide two or more lists and combine them into a single list. Okay, so the first list was var dot user locations, where it is, user locations, and second is var dot default location. Okay, it works the same way as merge. It just merge is for maps and concat is for string. Okay, so now we have merged it together. Okay, and if we were to print this out location, let's go in the output and let's add all locations. Value is equal to local dot all locations. Okay, and like tf plan, or let's do a tf output and let's just use all location. I don't want to print everything, right? So let's just use this. The output, yeah, because I haven't run tf plan yet, that's why it is not showing. So I have to run tf plan once so that it refreshes the tf state file, right? So now if I run tf output or location, it's still saying it's not there. Okay, let's run tf plan. Okay, I'm looking for the output variables. Let's see where it is. Okay, here is all locations. Now if you see in all location, because it's a list, it provided you all the values, right? And it has duplicates as well. East one, it has duplicate values as well, right? So what if you need only the unique values? Okay, for that, if you remember, only set has the unique value. So what I can do, I can create one more variable over here. So let's call it unique location, and instead of concat, we can use toSet. Okay, toSet function, that means we are converting this list into a set. Set only will have unique values. Okay, so let's use var dot all locations. Oops, sorry, not var, it's a local. So local dot all locations and hit save. Now if I add this in the output variable, output unique locations value is equal to local dot unique locations. Okay, so let's use tfplan hyphen grep unique locations. Okay, so I need few more lines after this because it's a list. So let's do grep hyphen a5. So it will show you 5 lines after this grep result a5. You can do b5 to see before results, but yeah, that's it. So if you see now, there's a list and it removed the duplicate value. It has only the unique value, US East 1, US West 1, US West 2. Only unique value because it's a set now. It's not a list. And this is what we did, the type conversion. We converted the list into set over here. Okay, let's go ahead to the next assignment, which is around the number functions. Okay, so we'll look into sum, max, and absolute. Okay, so let's create a variable. So let's create this variable over here. What it is doing, it's a monthly cost. It's a list with multiple values. Okay, so negative value means it's a credit. So this is debit and this is credit. Okay, now what you need to do, you need to do some calculations. You need to use some function like sum, max, and then you need to do the calculation based on these elements. Okay, so let's go inside your main and inside your locals. So let's do a few things. First, let's calculate only the positive cost. Okay, so for that, let's create a variable called positive cost. And now what we have to do, we have to iterate through multiple elements, right? Because there is no function to calculate the positive cost. So we have to iterate it through the multiple elements. Actually, you can use absolute function as well, but then you cannot use absolute in a list. In fact, let's try using it. So if I were to use absolute var dot cost, what was that, monthly cost? Let's see if it works. Positive cost equal to absolute var dot monthly cost. So let's create an output variable as well. Output and positive cost value is equal to local dot positive cost. Now tfplan, let's use it over here, the same variable positive cost. Yeah, it says invalid value for number required but have tuple. Actually, that's not even a list because it has a negative value. So it is a tuple, different data types within the list. So for that, because absolute function doesn't work on tuple, you have to iterate it using a for loop. Okay, so how do we do that? Absolute is fine, but then you have to use the absolute in a counter and we have to execute the counter. Okay, so for, let's say, cost in, we have used the for loop before as well, so I hope you understand it. In var dot monthly cost colon absolute. Now absolute should be on cost. On each of the counter it will check the absolute value and then use the what is saying? No declaration for var dot monthly cost. What was the variable name? Let's see. It was monthly costs. There was an S, monthly costs. Okay. For cost in monthly var dot monthly cost and then absolute cost. So now let's run TF plan again and let's see. It's not showing anything now, like there is no grab result, maybe because there is an error. So let's see TF plan. Okay, okay. But because positive, why it was not coming in the grep result, I'm not sure, because it's definitely over here. So what it is doing, it is checking each and every value and converting everything into absolute value. So everything is now coming as positive, even if we had one value which is -50. So everything is coming as positive now because we have converted everything into absolute values. Now that was for converting a tuple into positive values, like we are using a for loop for that. Now let's calculate the maximum cost. So if we were to calculate the maximum cost, let's show you this thing. So if I do maximum cost equal to max of var dot monthly costs, right? If I were to do this, this will again throw the error, because again, similar to absolute function, max does not work on tuple. These are functions for numbers or integers. It does not work on tuples. So for this as well, we have to run for loop. But because we have already executed the for loop and we already have the result in positive cost, we don't have to do it again. We can just do max of local dot positive cost. Okay. And similarly, we can do min as well, which is min of this, and we can also check total cost. Total cost is equal to sum of local dot positive cost, and we can also calculate average as well. So average cost is equal to, now average cost will be total cost upon length of total cost, right? So it should be local dot total cost divided by length of local dot positive cost. So length is 4, right? So that's how we calculate average. Now if I were to print all of these, let's go to output. So we have the positive cost. Let me just do it fast. Now we need not the positive cost, we need, let's say, total cost. So local dot total cost, then we have max cost, which is local dot max cost, then we have min cost, which is local dot min cost, then we have average cost. You get the idea, right? So average cost, local dot average cost. Now let's do a TF plan over here, and that should provide us all the details. Oops. Now it's saying local dot positive cost is a tuple of 4 elements, because we might have done something wrong. Okay, let's go back. Local dot positive cost is a tuple of, okay, it's showing max has issues, some has issues. Okay, so it's still not a number, right? It's still, so yeah, my bad. Even though we converted everything in the positive cost, it's still a tuple. It's still not a number. These only works in case of number separated by comma, right? So what you can do is you can create one more variable. I'm just trying it out. I might make some mistakes, so bear with me. We'll correct it together, don't worry. Okay, So if you remember, we worked through split function, right? So let's do that thing only. So let's create a variable name list cost. Okay, I'm just giving any random name. And what we're gonna do is we're gonna use split function, and we'll use the split function in local dot positive cost. Okay, and the second substring is, oh no, this is the substring and the first is the separator. So let's add the separator, which is comma. Okay, and now instead of over here, let's replace it with list cost. Now this should work fine, but let's see if it doesn't. So total cost equal to, yeah, TF plan. Okay, invalid value for number required, but have list of string. Oh, it doesn't work in list as well. Okay, because what we did, we converted that into a list. We could have used two lists, but still we need numbers separated by comma, right? So we need multiple values of a number. So for that, I think this is the only way we can use for loop. Okay, so instead of this, I'm gonna remove this as well. So let's paste it over here. Instead of ABS, let's set max for cost in var dot. You can use positive cost or monthly cost, doesn't matter actually. I'm gonna remove this part, and over here, that's the max cost. Over here is min. Over here is sum, and length should work. This is positive cost. Okay, let's run it again. Now it is throwing error, cannot sum non-iterable. Okay, invalid value for list. Total cost has some issues. Okay, what it is saying, for cost in var dot monthly cost. Oh, okay, because it has a negative sign as well, right? So instead of that, let's use the positive cost. Okay, not var, it's a local. And we are doing length also on the positive cost. Yeah, let's run it again. Okay, what it is saying, still throwing the same error for total cost, which is we are doing sum of all the elements in the cost for cost in local dot positive cost, which has a list. Oh, because we are doing it one by one. Okay, so yeah, it will throw the error for sum and invalid function. Okay, just wait. Let me think about it. What can be done? Okay, I understood the mistake that I was making. We don't need these four loops in max and min. So let me just replace it first. Don't need the split function as well. Okay, so the way we were doing max and min on this positive cost will not work, because this is a list, right? And this max function works on individual numbers. So what we need is a spread operator which will treat individual elements for max and min. Okay, and this should be min. So the spread operator is something like this. At the end of the variable, you just add 3 dots. Okay, same for min. That's it. Okay, and let's run TF plan. Okay, now it worked. So here's the total cost, 425. You can just check it out, 200, 300, 375, and this was plus 50 because we converted that into plus, right? So 425. and this is where the total cost is. Where are the other output variables? That's the positive cost. And then we have average cost, and then we have max cost, which is 200, min cost, which is 50. Okay, so every variable was printed successfully, and we have covered all the numeric functions now with this assignment. So let's move ahead with the next one, which is timestamp. Okay, so let's try to use different timestamps based on the timestamp function. For that, let's use locals itself. Okay, and let's simply start with printing the timestamp. Okay, so current timestamp is equal to, if you remember, we discussed about timestamp function. It does not need any argument, so let's just print this like this. And in the output time, okay, and value is equal to local dot current timestamp. Okay, let's print tf plan grep time. Okay, so it says time equal to known after apply, because we have not applied the changes yet. That's why it is not showing the current timestamp, so which is good. Okay, this is what we need. Let's go ahead and let's do some more formatting. Okay, so let's say we need in specific format, right? So let's use format1 is equal to format date. This is another function that use timestamp as the substring timestamp function, and also we need to provide the format. So let's say yyy mmdd. If you want, you can use mmdd like this. Like capital M means it will come in the uppercase, smaller m is lowercase. It doesn't matter if it's a numeric, but if you do MON, that means it will print the first three letter of the month, right? Like JAN in uppercase and so on, right? And then you use local dot current timestamp. So that's one format. And similarly, you can print another format, which is, let's say, yyy mmdd. Okay, and then you can also append that with the, let's call it timestamp name is equal to, append the timestamp with another variable, let's say backup hyphen, and using the string interpolation we can add local dot format1, whatever format we need, and then we can add this timestamp name in front of any variable. Okay, so you can put that in output variable and try it out. We have already seen that multiple times. Now we are in the last assignment of this video, which is around file handling. So we'll look into few of the file handling function. So let's create a JSON file to test this out. Okay, in the same folder, I'm gonna create, let's say, a file called config.json. This is the content. Okay, so what it has a database map with host, port, username, password, and API with endpoint and timeout. Okay, so that's config.json. And okay, so let's see if how it's gonna verify the changes. Okay, so let's inside the local, let's add a variable called config file exists. It will check the file. Okay, so how do we check? The file function is file exists. So that is the function using which it will check if the file exists or not. Now if you hover the mouse over it, will show you the path and the string. Okay, path, which is a string. So for that you need to do dot hyphen config. Dot hyphen is for the current directory, so config dot json. Okay, and if you want to see the data. If you want to print the data of the config file or whatever, then you can use config_data is equal to, first you need to check if the file exists. So local.config file exists, the first one. If it exists, so this is like a conditional expression that we have seen earlier, right? So we are saying if it exists, this is a condition, then question mark, which is the true condition, which is JSON decode. So the file is, let's say, encoded, we need to decode it. Okay, and inside that we use a file function and we provide the file path config.json, and yeah, it should be in double quotes. So we are using two functions. One is a file function to read the content of the file, and then we also have to decode the file content to print it. Okay, and then we provide colon and the false condition. So let's just put it blank. Okay, if the file does not exist, then it will print the blank. Okay, and I think now we can just add that in output variable, output config, and value is equal to local.config data. So let's run tfplan grep config. There is no function name format it. Okay, there is a typo over here, so let's fix that. Format date. Okay, there is one more thing. Whenever there is an incorrect name, the function name will come in white. Now that it is, it's based on actually the theme that you are using, but the name of the function will be highlighted if it's correct, right? As you can see over here. So let's run it again. Okay, yeah, it is coming as blank because there are multiple fields to it. So I'm gonna use grep-a10 to print the next n lines after the search, and as you can see, this is the config output. So it is printing the entire file over here. Okay, so that was few of the functions for file operations. You can test out more. You can check out directory name. There is we have covered file decode. There is file encode function, JSON encode function, and so on. You can check out the documentation and see if there are more functions that you want to try, but make sure you try out all the examples and make sure you complete the assignment. Make sure you submit the assignment. Again, if you don't do the hands-on, it won't be of much help, but I hope you enjoyed the video. I hope you liked the video. Thank you so much. I will see you tomorrow. Happy learning.